All right, so usually when I do introduction to Silex, it's more about telling you about how to use Silex, but that's kind of boring, so I really want to talk a bit more about the concepts and the ideas behind it. If you have any questions at any time, just ask them. Yeah, let's start. So, a few words about myself. I'm a philosopher slash independent researcher, which is a nice way of saying I don't have a job. I work on a couple of PHP projects, including Silex, so the Symfony. Well, I did some work on some of the Symfony components. I did some work on Composer, PHP, React PHP, if you've heard of that. Yeah, that's what I waste my time with. So I came across this concept just a few weeks ago called chunking, and I'm probably going to completely misrepresent it because I don't actually know what it's about, but it comes from this thing called neuro-linguistic programming, which is about using language to make people do things they don't want to do. So chunking is about abstraction. So basically, given any context, any situation that you're in, or any conversation that you're having, you can become either more abstract or you can become more concrete, which means that the concept of abstraction, or abstraction in general, is really something that's completely relative. So you can't really say this is abstract, you can only say it's more abstract than something else. So if you want to become more abstract, which is in chunking terms is known as chunking up, then you just ask why. So if you ask why, then you get the reason for why you're in that previous context to begin with. And if you want to chunk down, if you want to get more specific and more concrete, then you just ask how. And using just these two questions, you can navigate this almost multi-dimensional space of abstraction, where you can maybe also navigate sideways by asking, well, how else could I do this? What is a different way of doing that? And this just completely blew my mind, because it gives you a nice way, or a nice framework for thinking about abstraction and thinking about not just solving problems, but also, well, coming up with different solutions and finding out what the actual problem is that you want to solve to begin with. So, on a scale from 0 to frameworks, where do you think you are? And with these two parties of framework users and non-framework users, you really have different arguments that are all valid arguments. I hope you can kind of see this. So the 0 framework guys, the people who don't like frameworks, they're just going to look at those framework people over there. They're going to say, "Oh, you're so bloated, you're so fat, you can't do what I can do." And the framework users, they say, "Well, you're solving the same problems over and over and over again." And both of these are actually valid arguments. So I don't think this scale is very useful, because it doesn't really tell us that much about the problems that frameworks solve and the criticisms that you may have towards frameworks. So if you take a step back, if you chunk up and ask why, and ask, well, why do we have frameworks, or why should we care about frameworks? Which problems do frameworks solve? I think we can sort of group that into three main categories. So we have conventions, and this is mostly the community aspect around the framework. So you have things like coding standards, directory layouts, that give you a common starting point when starting a project, and that give you common conventions so that when you want to hire developers, you can maybe hire Zen Framework developers or Symfony developers, and they're already going to be familiar with all of those concepts that are specific to that framework. so you don't need to teach them over and over again. So you have a nice name attached to it, and you can build a community around it, you can build commercial services around it and whatnot. But really it gives you kind of a common base, I guess. Then we have the libraries. And this is really what people mean when they say don't reinvent the wheel. So there's so many common problems, more sort of infrastructure related problems like routing, ORM, templating, that kind of stuff that has been already solved so many times. It's been solved over and over again. And it doesn't really make sense for every single project to write your own templating engine from scratch, or to write your own database adapters from scratch. So you would really want to base your code on some pre-existing package that is well tested and you know is going to work, right? So that's what libraries are about. It's the common code that you can reuse. And then you have wiring. And this is kind of hard to describe because it's more of a fluffy concept. You could either put this into the conventions or put it into the libraries, but I put it as a separate concept because I think it's important to think about this explicitly. So when you have libraries, a library generally tries to be as flexible as possible so that you can adapt it to your specific needs. But as a user, you don't necessarily care about all of the small specific options. You just want to have a library and start using it. And maybe at some point you run into some problems and you might want to customize a little piece of it, but you don't want to start out by having to wire up all these small pieces together. So the wiring is about having some glue between the libraries or on top of the libraries that make them easier to use. So they give you essentially a usability layer on top. And they give you a bootstrapping for using them. Yeah. So if you look at these three concepts, and if these three concepts are what frameworks provide, then they're really kind of mashed together. So when you buy into a framework, when you invest in a framework, then you're getting all three of these things, but you're getting all three of them as one package, at least usually. So you have the Symfony umbrella term, which includes all of these things, and you have Zen framework term, includes all of these things, and pretty much every framework kind of works like that. And we should really take the time and ask why. I mean, why do we couple these things together? Because that's where most of the complaints come from, that it's not flexible enough, the framework makes too many decisions, tries to take control of the code base, and that might not actually be necessary. So why are they coupled together? Why can't we have these as individual packages? Why can't I have one package for the conventions, one package for the wiring, and then for the libraries, one package per individual library that this framework provides? So why? Let's chunk up one layer of abstraction. And the reason is because downloading stuff is hard. I think this is one of the main reasons why frameworks have become so monolithic, because it's just hard to make these small packages and hard to distribute them. So because of this leads to a lot of problems. But there's actually a solution to this problem, and you've already heard of it today. It's Composer. And this is the Composer logo, which wasn't loading on your presentation. So now you know what the Composer logo looks like. So Composer solves exactly this problem of distributing small packages and having a mechanism for also resolving the dependencies between them. Okay, so if we have that problem solved, then maybe we can go back down and look at these three things, maybe look at them as individual concepts and try to separate them, and maybe actually make individual packages out of them. And the way that I'd like to organize this is something more like this, because it's really sort of a stack in a way, where you have libraries as the base. I mean, that's what everything's based on. The actual code that you want to reuse. So that's the libraries. And then you have a wiring layer on top of it, which gives you some more usability for those libraries. And then you have conventions on top of that. And the nice thing about this is that the conventions and the wiring, they're really optional. You don't have to use them. You can just use the libraries directly if you want to. Or you can use the libraries plus the wiring and ignore the conventions. So this gives you more choice, which is good because it addresses all of the issues that, or maybe not all of them, but most of the issues that arise with monolithic frameworks. So this is maybe still not the perfect scale, but I think it's a better scale of looking at frameworks. So on the scale from libraries to frameworks, where do you think you are? So now we have at least have something more concrete to talk about, which brings us to Silex. So is anyone already familiar with Silex at all? A little bit? Okay. So Silex, there's kind of three main points or main responsibilities that Silex has that I want to go into. And for the most part, Silex is just a glorified router. That's really all it is. People get so excited about it, it's insane, because it doesn't actually do anything. It's just a nice little piece of code, a nice little router, and it's more about the things that Silex doesn't include than about the things that it does. So maybe people get excited about that, I don't know. So let's see what this means. And by glorified router, so I guess the term micro framework, however buzzwordy that may be, that's all it means. It's a glorified router. So this is how you use it. This is the hello world of Silex. Maybe you want to switch off the light real quick so you can at least see the code sample. Well, it's nothing special. You create the Silex application, and that's kind of the main or the only interface that you get into Silex. And this contains a couple convenience methods that delegate to other internal objects. You don't really have to care about that. All you need to know is you create this application, and then you can call methods on it, and then you can run it. And when you run it, it will actually take the request and run it through the application and give you the response. So just a couple things that you can do with it. So you can think of it as a controller framework, really, where you map a route or a path, and you add constraints onto that, and if all of those constraints match, then a certain controller will be executed. And this controller is just a function from request to response. It's just a function that takes a request object and returns a response object. And this function could either be an anonymous function like this one, or it could be a method on a class. And this doesn't actually have to be a static method, by the way. So Silex will actually create an instance of that class for you. And you can add constraints like here, so you can say the ID needs to match this certain regex, and the get, post, put, delete, match. You can match on any HTTP method, really. And that's pretty much all there is to Silex, really. There's a couple other neat things. So you can add event listeners, and there's a few events, so you can do something before every request. And that's kind of useful if you want to do authentication. So you want to say, well, if this user is logged in, I want to do this, or maybe check if the user is logged in and otherwise return a 400 response, or a 403, or a 401, or whatever. You can do something after the request. So that can be nice if you want to maybe mess with the cookies, or want to encrypt or sign the cookies. So you can do that kind of stuff, basically at the HTTP layer. And with finish, that's kind of neat actually. So finish will run after the response has been sent, which means if you want to do expensive API calls, expensive DB calls, you can put those in a finish listener, and it's going to be kind of asynchronous. So not completely asynchronous. If you want to do this at scale, don't use finish, use a real message queue. But for basic use cases, this is actually kind of nice. Except you don't get the error handling, so you need to make sure that it doesn't actually break. And then you can also do error, well, you can attach an error listener, which is just a different type of listener as well. So whenever an exception happens within a controller, then this code will be called. And there's also a default listener that will just display a generic error message. But if you want to have a more customized one, this is how you do it. And you can catch specific exceptions as well. So you can say, well, if I have a not authenticated exception, then I want to render a different type of response. Yes?
Can you catch errors for specific routes?
There's no easy way to do that, but it's easy to extend Silex to do that. So you can catch all errors and check which route was matched. You can name routes, so you can check if the name matches that particular one. Or you can do some hackery. Well, it's a bit more complex, but once you look at the internals of Silex, it's actually quite easy to do that. So it's possible, but not supported out of the box. And then there's a few convenience sort of response factory methods. So you can create a redirect response, a JSON response, or a binary file response, which will send the contents of that file with any content type that you specify. And these are really just convenience. So you could also create instances of the actual various response subclasses that will do exactly the same thing. So the second, first of all, any questions about that part, about the routing? No? Okay. So the second one, the second sort of broad topic that Silex covers is a dependency injection container. Is everyone familiar with what dependency injection is? Yes? No? A bit? All right, I'll just go over it real quick, maybe show a quick example. Actually, I don't think I have an editor, so I'll just try and explain it. So, dependency injection is really just a fancy way of saying taking an argument. So, basically it means whenever you have a class, any other class that class depends on, or maybe better in terms of objects. So whenever you have an object, any other object that object depends on, you're going to pass it to the constructor. So instead of creating the instance within that object constructor, you create it outside and then pass it in, so you inject it. And you can apply this pattern over and over again to an entire code base. And when you do that, you get a little bit of bloat, but you get extreme flexibility because it allows you to change any instance of any class in the whole system. So essentially what you end up with is one huge sort of main file that just wires everything together. And then, I think I stole his laptop. That wires everything together, so you have this huge file that just creates all of these objects. And so you need to maintain that, and that is kind of where it gets painful when you do it. So to solve that problem, there is what is known as a dependency injection container. And the way this works in Silex is that the Silex application class extends Pimple. And Pimple is the worst name ever for a project, but it's a very simple dependency injection container that allows you to define services. And a service is really just an object that is managed by the container. So let's take a look at a few examples. These are services that are defined inside of Silex. So when you create the Silex application instance, it's going to define all of the services in the Silex constructor. So when you do, let's see, when you do new Silex application, you already get a fully configured container with all of the services predefined. But those services haven't actually been instantiated yet. So they're defined, but they will only be instantiated once you access them. So that's the laziness aspect that you get. So this is how you access them. It uses an array access type interface, which you may or may not like, but that's the way it is. So this is how you get services out of the container. And the root is just the root collection that Silex uses internally. URL matcher, kernel, those are other services that are also internal. But you can actually fetch them out and work with them. So you can, if you want to, you can manipulate them. You can take the root collection and add something into it directly, as opposed to going through all of those methods on the application class, which can be nice if you want to extend it. There's also parameters, which work pretty much the same way. So you just define your own parameters using this array access interface. You can also read parameters that way. And what's nice about these services is that you can actually override them. So you can override the predefined existing services that are defined on the Silex application and replace them with your own ones. So if you have your own URL matcher, you can just plug that in and define a service using this function syntax. If you're interested in how this actually works, just read the documentation. It's really well documented. But this just returns whenever the URL matcher is accessed from either outside or inside Silex, it's going to return that object, which can be a custom one. And you can also define your own services. So if you want to have your own application-specific services for your website that you're doing, you just define them exactly the same way. And here you can see how the dependency injection works. So this service foo is an instance of the class foo. But as you can see here, in the constructor, it's actually passing another service. So it's passing an instance of bar, which means foo depends on bar. And you can apply this over and over again. So foo depends on bar, depends on bars, and so on and so forth. And then if you want to replace just bar, you can replace that one without changing foo. And then you can access it the same way. Okay, so those are the main things that Silex itself actually gives you. On a more sort of philosophical note, I like to think of Silex as a user interface for Symfony. So Symfony, well, Silex is based on the Symfony components, and Symfony is sort of split up into these two main parts, where you have the Symfony framework and the Symfony components. And the components are really just libraries. So if you go back and think about the individual responsibilities that a framework has, it's really that low-level library concept. That's in the components. And the framework builds on top of that and gives you the wiring and the conventions. So Silex takes the same base as Symfony, it takes the same components, but it gives you a different wiring. So it's a different wiring, a different user interface on top of the components. The user being a developer, you guys. So here we can see these things at the bottom here, those are the Symfony components that Silex uses. And it's just based on top of those and gives you, it's really a thin layer that gives you a nice way of using it. Well, it's a wiring, really. So one of the most important components that it's based on is the HTTP foundation, which gives you request and response objects. So this is a Symfony component, and it really just does just that. It just models the HTTP request as an object and the response. So instead of using all of those super globals, instead of using things like echo and exit and header and whatnot, which tends to be quite messy, you actually use these objects, which helps a lot in making sure that the access to those methods, or the access to HTTP itself, is kind of scoped. Because the main problem with those superglobals is they're global, they're super global. So you can access them from anywhere, and you can access echo from anywhere. So any function that you call at any point in time could send out random headers, or could create a new cookie, or send out output. And it's really hard to actually manage that and see where that is happening. Whereas if you have request and response objects, that kind of scopes your capability to those objects, meaning you can just follow the code to see where the objects flow, and anywhere where they don't flow, there's not going to be any HTTP specific code happening at all. So that kind of helps. And I think it makes quite a big difference in code maintainability, since it gives you these value semantics. The request is just a value. It's an object that represents that value of that request message that you got on the wire. And the same thing for the response. So Stack. This is kind of a side project, but I just wanted to mention it. Stack it's not really a project, it's more an idea with the name Stack attached to it. So if any of you are familiar with rack middlewares from Ruby, maybe, this is basically trying to do the same thing in PHP. So think of it this way. If you have a Silex application at the bottom, and this contains your own application code, then you can stack layers of middlewares on top of that, and the middleware is just an interceptor for request and response, and you just kind of wrap it around the application. And this is based on a Symfony HTTP kernel, so it doesn't actually need a Silex app. It could be any HTTP kernel, any framework that implements HTTP kernel. So the way it works is a request traverses these middleware layers, and each layer gets the opportunity to respond to that request or delegate to the next one. So then it goes through until it hits the application, at which point it gets the actual response, and then the response propagates as well through the layers. So again, each layer gets the possibility to respond or to modify that response in some way. And this is really nice for things like authentication, because you can just add an authentication middleware before it. And since it's based on this HTTP kernel, it means it's completely composable with lots of different frameworks. So it's going to work with Laravel 4, Drupal, Symfony, Silex, a bunch of others, and which means it's really nice and reusable and pretty much framework agnostic, as long as the framework implements that interface. Yes?
You actually need to have Silex at the end of the chain, or it could be anything, anywhere?
Well, the way it works is the middleware is actually a decorator, so it needs to decorate, it needs to wrap around the application. So you can't really add a Silex application in the middle. What you can do is, there's actually an existing middleware which is a URL map, where you can have URL prefixes, and if the request matches that prefix, then it's just going to delegate to the other application. So you could have kind of a routing before the routing, sort of.
Okay.
All right, so yeah, that's Stack. So many people ask me, what is the difference between Symfony and Silex? And when should I use Symfony? When should I use Silex? When should I use something else? And I didn't really have a good answer to this question for quite a long time. It kind of took me a while to figure out the essentials of it. But I'd say the main difference is really conventions. Symfony ships with a lot of conventions, and it tells you exactly how to do things. They have bundles, they have a default directory structure, they have coding standards, and so on and so forth, that tell you how you should organize your code. And it really takes control of what you're doing. Whereas the approach in Silex is to start with nothing, or to start with the bare minimum, and add the things that you need. And I think this is pretty much in line with Composer, because it really just gives you the routing, and then when you need an email library, you add the one that you need. When you need a templating engine, you add the one you need. And it gives you more choices. Whereas in Symfony, while you still have the choice to change those decisions, there are already decisions made for you, and you're going to have to remove what is there and replace it with your new choice. So I think that's kind of the main difference. And then there's a few other things, but those are really just minor points. So Symfony does a lot of static compilation, writing lots of cache files, whereas Silex is just everything dynamic in memory. And Silex is generally more lightweight. But then again, depending on what you're doing, your mileage may vary. So benchmark it yourself if you really have the need. Like if you have a really high traffic website, you might want to make your own checks. So just to recap, Silex is really just a glorified router. It gives you routing and events and a couple convenience things. It gives you Pimple, the dependency injection container, which you don't have to care about if you don't want to. So it's there if you need it. You can ignore it if you don't care about it. And it's a user interface for Symfony. So on the scale from libraries to frameworks, it's pretty much in the middle. It gives you libraries, the Symfony components. It provides a wiring on top of those libraries to make it more usable, but it doesn't have the conventions. And you need to figure out yourself where you are on this scale and whether you want to have something that takes more control or if you want to have more freedom. That's really up to you. So that's it. Do you have any questions? Yes?
I just wanted to ask about that stack project.
Yeah.
Can you give me like a concrete example of what one of those middlewares are? Like, are they PHP like libraries, or like I'm still trying to imagine exactly what one of those is. I can imagine perhaps some kind of caching or something like that.
I'm just gonna see if I have internet here. Maybe I can show you an example. I think these are all protected.
Okay. Just a minute.
Yeah, you can. You can hide the characters if you want.
Oh, it's okay.
Everybody knows your password now.
You found.
Now if you remember this network, if you're ever in the area, you can steal your signal.
Yeah.
It's still connecting. Yes,
Perhaps no.
I don't think it likes me. Is it loading? Nah. Okay, so maybe I can try and explain the URL map in a bit more detail, because that's quite a nice one. So the URL map is just an object that takes to the constructor an application that it will delegate to. So that's kind of the fall through, which means that if none of the other routes, which I'm going to go into in just a sec, match, then it will just delegate to that application. And that can be a 404 page, or it can be an actual Silex app that does something. Now, the other argument that you give it is a list, which is really just a mapping from prefixes to other controllers or applications. So you can mount an admin panel under a /admin prefix, and if that prefix matches, when the request comes in, it will first check the list of well, the list of things that it can delegate to. So it sees the admin prefix, delegates to that one. If there's no admin prefix, it just delegates to the normal application, which could be a Silex app, could be something else. It's kind of hard to explain without code, I guess. But I hope I could give you an idea. Just check out the Stack website and some of the Stack examples.
I think the trick in this case is just that you can take a number of existing applications that weren't really designed with being embedded anywhere else in mind, but you can just kind of stick them together and make one thing out of them. So this doesn't just work on like a library basis where you have to write code to glue them together, but actually on a complete application basis.
Well, one of my biggest problems right now, why I was asking this practically the same question before, that I built a REST component for WordPress, and it's awfully slow because of WordPress, because the routing of WordPress is awful. So I was wondering if that kind of thing could actually help me. You know, you just detach the whole thing from WordPress, let WordPress handle whatever it wants to handle, but all that data framework that provides the REST interface, I could actually put it in a new application and make it blazing fast, right?
Yeah, that's basically exactly the same approach.
The problem...
I've actually had experience with WordPress plugins, and you can just use the routing component from Symfony, which can accomplish what you want to do in much more depth. Yeah.
Yeah.
Or you can write your own based on those specifications.
Okay.
It is quite feasible.
Okay.
Well, or you can just use Silex and do the pre-routing thing yourself. So you can just check the server super global, just check the path, the request URI I think it's called, and if it matches your prefix, then you just execute your own code, otherwise execute WordPress.
Right. I mean, the tricky part to that is that WordPress doesn't actually follow this whole request response thing because it doesn't use the HTTP foundation.
Yeah.
But so you're going to have to write some kind of glue code to get WordPress to the response from WordPress into this then a response object to pass it through there again. But that's typically not that hard. It's actually so when we started thinking about, like I mentioned earlier, that PHP wanted to start using Symfony. This was actually one of the first things that like I realized was cool about like the Symfony concept of this HTTP foundation. And I think before Symfony 2 was really still very new, and we hadn't done any of that. I just built a small demo app where you had, I think it was Joomla one time and Drupal the other time. Well, I mean, Drupal at this point uses this anyway. Just running inside of one of these HTTP foundation request response thingies. And you have to write some kind of like small piece of glue code here and there to get like cookie things to the right places. But it's not very hard, and the result is that you can really build like an application consisting of, you know, a Joomla for these kind of URLs, WordPress for those, and Drupal for these, and you can just stick all that stuff together.
It's going to make a pretty messy folder, but...
Sure, but the thing is, if like in this kind of a case where, you know, you have this thing anyway, and now you're going to want to add something onto it, rather than having to, you know, continue in that style, you can actually just make the choice to delegate some part to that old thing which you can't touch, and then just build your other stuff.
It does get kind of messy, especially... Yeah. I don't think it's going to be possible to do it with WordPress, because as soon as you have an exit call in there, you can't really wrap that in the same way. It's just
right.
stop execution.
Yeah, but there aren't many exits in WordPress except for the redirections.
Mm-hmm.
But apart from that, it's really a full start from index.php, go through everything, and then exit from index.php.
Yeah.
So it could be wrapped up to some level.
Yeah. So here's an example of the URL map. So you have the main application here, which is just the Silex app. Then you have the blog, which in this case just returns the string, this is a blog, but it could be an actual blog. And then you have the mapping, which maps this /blog prefix. Let me scroll a little bit. Sorry about that. So you have this /blog prefix mapped to the blog itself, and as you can see, the blog itself actually starts on / and it will prepend the prefix to that. So /blog/ will then return, this is the blog. So yeah, kind of neat. All right, any other questions?
To finish my thought from earlier, that's actually like the point why I built these demos was, so if PHPV through this becomes embeddable into any other software, I mean, kind of a forum is typically not something you run on its own. So it would be very convenient if you can just do like something like on these lines to get a forum into any other kind of software that you have.
Yeah, and that it also means that you can compose it with anything that follows this pattern. So if you have an authentication layer that works like this, that you just have as a middleware before, then you can actually have a proof of concept for that for OAuth, where you just add one line of code in your main index.php file, and you get OAuth Twitter login. And it intercepts the /login request and responds with a redirect to Twitter and manages all of that authorization stuff for you. And you can then compose that with anything else. So you can compose it with Silex and with any of the other frameworks, as long as they're compatible with this request response. Anything else? Any questions? All right, thanks.